Hello everyone, I am Avinash Koda. Today I am going to explain some of the most important topic in descriptive mathematical structure, particular order and assay diagram. First I start with the particular orders introduction. Particular orders are the specific type of binary relation that exhibit certain properties. They help in organizing elements based on a definite relationship such as divisibility and subset inclusion. Understanding those orders is crucial for studying lattice theory and combinators. Definition of particular order. A particular order is a binary relation that is reflexive, antisymmetric, and transitive. Reflexive means every element is related to itself. Antisymmetric means two elements are related in both directions and they are equal. Transitive indicates that if one element is related to second and the second is related to third and then first is related to third. And then what are the examples of particular order? The relation of a subset inclusion among sets is a classical example of partial order. A relation of divisibility among integer can also be represented as partial order. These examples showcase how certain properties can define order among elements in a set. And now, introduction of assay diagrams. Assay diagram is a graphical representation of finite partial order set. It simplifies the visualization of the relationships between elements by omitting the transitive edges. Assay diagram help illustrate the structure and properties of particular order clearly. And then construction of assay diagram. The construction of assay diagram start by identifying the element of partial order set. Next, draw the elements as a point in a plane, positioning them based on their order relationship. Finally, connected to the points with the lines and the represent immediate relationship, avoid the transitive connection. This is the diagram for assay diagram. What are the properties of assay diagram? Assay diagram are cyclic meaning there are no loops and cycles in the representation. They reflect the transitive relationship without explicitly showing all connections. Each element is positioned higher than the element it is related to, visually representing the order. Interpretation of assay diagrams. The vertical positioning of elements indicates their rank in the partial order. A path from one element to another in the diagram signifies a direct relationship between them. Assay diagram provide a insight into the structure of the order, revealing the chains and the anti-chains. And now move on to the applications of assay diagram. Assay diagram are widely used in mathematical research to illustrate the various order relations. They also have application in computer science, including data organization and retrieval. In addition, assay diagram can aid in understanding hierarchical structure in real-world system. Chains and antichains. Chains is a partial order set, is subset where every pair of element is comparable. Antichain conversely is a subset where no two elements are comparable. Assay diagram effectively illustrates the presence of chains and antichains with a set. Lattices and assay diagram. A lattice is a special type of partial order set where every two elements has a unique least upper bound and greatest lower bound. Assay diagram can represent lattices, showcasing their interrelationships of the element clearly. The show and see the diagram, you can understand what the assay diagram represents as lattices. The structure of lattices can explore the visually through their corresponding assay diagram. Comparability and incomparability. In assay diagram, comparability refers to elements that can directly relate in the order. Incompatibility indicates that there is no direct relationship between two elements. Understanding these concepts is essential for interpreting assay diagram accurately. And then move on to the limitations of assay diagram. Assay diagrams are typically limited to finite partial order set due to the complexity. They may become cluttered and challenging to interpret with a large number of elements. The lack of explicit representation for transitive relations and can sometimes lead to misunderstanding. Software tools for assay diagram. Various tools are available for constructing and visualizing assay diagrams. These tools often provide user-friendly interfaces for inputting elements and relationships. Automation through software can help in managing larger sets that are impractical to visualize manually. In the conclusion on assay diagram, assay diagram play a crucial role in visualizing and understanding partial order. They provide a insight into structure and relationships of elements in a set. Mastery of assay diagram is beneficial for advanced studies in mathematics and computer science. Thank you for listening the video.